Hey everyone, welcome to the elaborations of exercise 16, which is a plus exercise with our reason, because this one is quite a bit more in-depth than the other exercises in this chapter. Let's take a look at this question. In isosceles triangle ABC, AC equals BC and AB is equal to 4 centimeters. The altitude AD equals 3.5 centimeters. Draw this triangle. I think personally, if you're going to start this exercise, in this case, it's easier to first draw the altitude AD. I will show you why in a moment. So I will take out my protractor here. I'm going to use my protractor because I need 3.5, so I can use my grid spaces exactly here. That is a terrible line. Let's do it like this. So around here, right? Let's get rid of this thing right now. So this is going to be point A. And this is going to be point D right here. What do we know about altitude? Well, we know that an altitude is always perpendicular to the line on it. So what I could say right now, and I'm going to do that in a smaller font, I know that B and C should be somewhere on this line. Why? Well, because I know this is an altitude, and an altitude is always perpendicular on the opposing sides. Well, where exactly are points B and C? Well, luckily, I do know in this case that AB is 4 centimeters. A is here. How can I now calculate how long AB should be? Well, what I could do is now turn my pair of compasses to 4 centimeters, which is right here. If I'm now going to draw, I'm not going to do this in red. No, thank you. Let's do it in black. If I'm now going to draw this circle, like, for example, oh, now I'm messing up a bit, guys. Like this. It intersects right here, right? So, in this case, point B must be here. Why? Because this distance is now exactly 4 centimeters. So I could now already draw this line right here. This line is part of AB. But where exactly is, in this case, point C? Well, we know that AB is going to be my base. Why do I know that? Well, AB is 4 centimeters. AC equals BC. So those two should be the legs of my isosceles triangle. And this should be my base. Which means that in this case, AC is going to be equally long to BC. And what I know is that let's take a look. I must say this correctly. That the angles there should be the same as well, right? So what I should do here is take a look. This is my base. The angle that is right here should also be right there. So what I could do is take out my protractor. I'm going to turn it a bit like this. And I can now measure this angle. This angle is going to be around measured correctly, right, is 59-60 degrees, you could say. Okay, so that angle should be, in this case, be here as well. So if I now turn my protractor around and go like this, 60 degrees, that means it should be in this direction. Return your protractor to this angle and now draw the line like this. Now I'm going to get rid of this thing again. And now point C should be here in such a way that in this case this angle B, should be the same to this whole angle right here. And then you find angle C to be right there. And it should be still on this line here. Why exactly? Well, otherwise my altitude won't be perpendicular on this line, right? So this, I think, is quite a difficult one because you have to use different theories, different pieces of knowledge to find this one, and you should understand an isosceles triangle quite well to understand this exercise. Okay, good luck. If you have any questions left, please ask.